This is a video from the topic B6, Inheritance, Variation and Evolution, and we're looking at inherited disorders and also embryo screening. So this is polydactyly. This is a dominant trait. So it's quite a common trait, and it results in extra fingers and toes. So, because it's a dominant trait, what genotype, so what pair of alleles would we have to have polydactyly? Okay, so the genotype is the double code of genetic information, the two alleles. So it would be either big B, which is homozygous dominant, or it would be big B, little b, which is a heterozygous genotype. What genotypes result in not having polydactyly? It is little b, and we would describe that as a homozygous recessive genotype. Now, I choose to use the letter B. The exam question may tell you what letter they want you to use, but B is quite a good one because you can see the difference clearly between the capital and the lowercase. So we've done two Punnett squares here. First of all, looking at two heterozygous parents, so both parents have got polydactyly, okay? And if we look at the top of that left-hand Punnett square, you can see we've got the big B and the little b. So they could be the mum and the two possible eggs that she carries, one that carries the polydactyly gene and one that doesn't. And then on the left-hand side there, we've got the dad's sperm, and that could be a big B or a little b because they're both heterozygous genotypes. So we match them up, and it doesn't actually matter if you put the big B first or the little b first, you won't get marked down for that. But what's really useful to do at the end is to analyse it. So if I was analysing this, I would draw a circle around all of the genotypes that result in having polydactyly. In this case, the big B, the big B, little b, and the one below that's also big B, little b. And I would analyse that as 75% chance of having polydactyly. So I'd put a big loop around those three. Let's look at the Punnett square on the right. Here we've got a homozygous recessive parent at the top and a heterozygous parent on the side. So we've matched it up again, and this time we've got two combinations of the offspring that are big B, little b. So I would circle those two genotypes that are big B, little b, and I would write next to it 50% chance of polydactyly. Now, the question may say that a couple have had 3 children and they've had 2 with polydactyly and 1 without. What's the possible chance of the next child having polydactyly? It doesn't matter what the children have had before, okay? We still say the same percentage chance that we did last time. So in the case on the Punnett square on the right, it is still 50% regardless of how many children they've had and what those children have their phenotype looking at, okay? So what is their physical characteristic? Do they have that extra finger or toe? Moving on to cystic fibrosis. Cystic fibrosis is a build-up of mucus around the organs. Okay, so it makes digestion and absorption of molecules very difficult. Also has massive impact on the lungs. There is a video in the B6 playlist that you could have a look at that tells you about cystic fibrosis from the Cystic Fibrosis Society. So if you need to know more about it, have a look at that. And we'll again look at the same process. So cystic fibrosis is a recessive trait. You can only get cystic fibrosis if you have 2 of the cystic fibrosis alleles. Okay, so here we've got little b, little b. That's the only genotype that will give you cystic fibrosis. So the genotypes that result in not having cystic fibrosis are big B, and big B, little b. We have such a thing as a carrier. In any recessive trait, we have carriers. And a carrier is someone who carries the allele but does not have the cystic fibrosis themselves, okay? So a carrier is a heterozygous genotype, big B, little b. And what we tend to find is that people who don't have cystic fibrosis can actually pass it on to their offspring, and that leads us into talking about embryo screening shortly. Okay, so let's have a look if we've got two carrier parents. So they're on the left-hand side, they were looking at that Punnett square. Neither of these parents have cystic fibrosis, but they both carry the gene for it. Okay, analysing this Punnett square is slightly different from the way we did the polydactyly. You can see there we've got one genotype that is little b, the genotype to have cystic fibrosis. So we would circle that genotype and write 25% cystic fibrosis. We would then circle the big B, little b, the carriers, and write down 50% carrier of cystic fibrosis. That's our analysis of the Punnett square on the left. The Punnett square on the right, we've got someone with cystic fibrosis and we've got someone who is a carrier. And here we've got a 50% chance that the offspring will be a carrier, the big B, little b at the top there, and we've got a 50% chance that they will have cystic fibrosis at the bottom there. Now we've looked at a dominant trait, polydactyly, and a recessive trait, cystic fibrosis, but it doesn't mean that they will talk about those particular two inherited disorders in the exam. But if you understand how a dominant trait works and you understand how a recessive trait works, you can use what you've learnt here and apply it to that new situation. Okay, so don't be put off if they talk about a recessive trait, but it's not cystic fibrosis. Just use the ideas with the idea of the carrier and analysing your Punnett squares and you'll be fine. So that leads us on to our final point, embryo screening. If the parents know that there is a history of something like cystic fibrosis in the family, they may decide to have embryo screening. This is where some cells are removed from the developing embryo, which can cause a risk of miscarriage, and those cells are tested for genetic disorders. Now, let's say the couple have decided that no matter what they find out from this genetic screening, they are going to have that baby. In actual fact, there's no point risking the baby by having the embryo screening. But if they decided maybe cystic fibrosis was a possible outcome for this offspring, they may decide to have the embryo screening with the view that they might abort the baby if it has cystic fibrosis, because they might be thinking about the quality of life that that child may have. Now, we don't have to have an opinion whether we agree with it or not. All we need to know is, when is embryo screening appropriate and when is it not, and why might someone use it? Okay, so if it's polydactyly that you're concerned your child may have, then really you're not going to go for embryo screening because it's not life-changing. Okay, if they are born with an extra finger or toe, that will be removed and they'll probably know nothing about it. But for other conditions, some people like to have embryo screening to see if their potential child is going to have a particular genetic disease, and then they can make their decisions following that. Hope you found that useful. Thank you.